All right, so this is week 4, day 2, quadratics and linear systems. We're going to be graphing them. Actually, they're linear inequalities. I should probably change that on the title. Let me go ahead and do that. But linear whoa, where is that? Where did that go? Inequalities. Graphing less than, greater than, that type of stuff. But that's on the back side. Okay, on the front side is, I think, the harder part. On the back side is the easier part. We're going to do 4 of these. We're going to do question 1, question 5, and then we'll do 7 and 11. Okay, so 1, 5, 7, and 11. So let's go ahead and just jump into this because we do have a short day today, right? So they're going to want us to sketch the graphs of each function, identify the max and mins, find out what the axis of symmetry is, and identify the zeros. Remember, the zeros, the solution is where the graph crosses the x-axis. If the graph does not cross the x-axis, then it has no solutions. If it does cross the x-axis, then you list how many times it crosses it, right? Wherever it crosses it. And you can just give me an approximation for that. But let me show you how we do these. We're doing 2 on this front page because one of them I want you to do where the equation is in standard form. This is what's called standard form right here. Okay. And then the other one's called vertex form, which is easier. But you know, we'll do that at the end. Okay. But let's do the first part here. So question number 1. So they gave me a y equal to 2x squared plus 4x plus 5. They want me to graph this and list a bunch of stuff. So here's the first thing I'm going to tell you guys to do. You're going to want to list your a. Your a value is 2. Remember, that's kind of like your slope, right? It's kind of like a slope. Not really, but from our vertex, we can execute one slope from there in both directions, up and to the right, up and to the left, or maybe down and to the right, down to the left. But we'll get to that in a bit. Then we're going to find our axis of symmetry. So our axis of symmetry is x equal to negative b over 2a. I know that b is 4. I know that a is 2. So x is equal to negative 4 over 2 times 2. Well, that just equals negative 1 because 2 times 2 is 4. Negative 4 divided by 4 is negative 1. So remember, they asked us for our axis of symmetry. There it is. X equals negative 1. Okay? Then they want us to find a max or a min. Now, in order to find a max or a minimum, we need to know our vertex. The vertex is done like this. You're going to list your axis of symmetry as your x value, and then you have to solve for your y value. Okay, so the answer we got in the previous step, the axis of symmetry, the negative 1, we're going to put it as our x value for our vertex. We're going to plug in the x value into our equation, and that's going to give me my y value. Okay, so let's go ahead and plug it in. So this is y equals to 2 times negative 1 squared plus 4 times negative 1 plus 5. So this is 2 minus 4 plus 5. That's equal to 3. So y is equal to 3. Okay, so this piece right here that I'm supposed to solve for, okay, that's going to be a positive 3. So there's my vertex. Now I can graph and do everything else they want me to do. So notice, in order to get started with these problems, it's good to identify your A term. It's good to identify your axis of symmetry. It's good to figure out your vertex. Let's get that point. Let's put it on our graph. So negative 1, 3 is right here. Okay? Then remember how I told you that your A term is like your slope? So I'm going to basically pretend that my slope is 2 over 1, right? It's the number 2, a equals 2, but 2 over 1. So I'm going to go from that red dot up twice, once to the right. That's 2 over 1. Also up twice, 1 to the right, to the left, I mean. And now I can just draw my picture. So the last thing, so this is a minimum, right? So they wanted to know what's your minimum. So your minimum is right there. It's a minimum of 3. A minimum of 3. That's the low point. Now, if this was opening downwards, it'd be a maximum. Remember, I don't know if you guys remember when we did this in the notes, but if A was positive, it's a minimum. If A is negative, it's a maximum, right? So, but you can look at it on your picture. So the last thing they wanted us to do is tell them what the solutions were, right? So like if we look at the instructions, it says sketch the graph of each function, check. Identify the max or minimum, check. What is the axis of symmetry? Well, x is -1, check. Identify the zeros. Well, did this graph ever cross the x-axis? The x-axis is down here on the bottom. Did it ever cross it? No. So it has no solutions. Okay? So I'm going to write no solutions. Okay? So I'll kind of highlight the things that they asked us for, okay? They asked us for a graph. So here's the graph. They asked us to figure out the minimum, so that was part of the answer. The solutions. They wanted us to list the axis of symmetry, right? So those things right there. So sketching the graph, I highlighted it blue. Identify the max or min, I highlighted that blue. What's the axis of symmetry? I highlighted that blue. And then what are the zeros? I highlighted that blue as well. Okay. So the stuff in blue is the stuff they're asking you for. But notice I had to do all the other stuff in order to figure it out. Okay. So remember I told you this is the harder way. What's the easier way? Well, let's go to question, whoops. Let's go to question number, what was it, 5. They want us to do the same thing. Find the axis of symmetry, graph this thing, find out if it's a maximum or a minimum, okay? So I'm going to kind of go through some of the same steps, not all of them. I know that A is -1. Remember, that's kind of like my slope, right? Down 1 over 1 in both directions, okay? So A is -1. Now, my axis of symmetry, that's just x equal to h. What's my h value? It's what? It's, well, 4, but -4, right? It's the opposite of what you see inside the parenthesis. So notice I didn't have to calculate anything. And then I got to know my vertex. But since this is called vertex form, this is pretty easy. It's just going to be -4, comma what? It's hk. What's my k value? Let me write it down, actually. It's supposed to be h comma k, so it's -4 comma 4. Yeah. All right, let's graph. So -4 comma 4 is right here. My slope is to go down once and over once in both directions. So down once, over once. It's right here and right there. Okay? And then you're supposed to draw the graph. So I'm just going to draw a graph. Now, I got to write whether this is a maximum or a minimum so I can see that this is a high point. This is a maximum of, well, the highest value is 4. Right there. Max of 4. That's the height. Remember, max and mins, they're asking you what's the height at the highest point? What's the height at the lowest point? Right? So max and mins. And then the last thing is going to be the zeros. Now, does this graph cross the x-axis? Yeah, it does, right? 2 times. Now, you might say, well, mine didn't cross where yours did. That's okay. Right here and right about there. Just give me an approximation. So I'm going to say x equal to -2 and -6. Now, if yours look like they crossed at like -2 and -5, that's okay. Just, write down your best guess. So I'm going to highlight in blue what's important again. They wanted the maximum. So there it is. They wanted a graph. So there it was. They wanted zeros. So there it is. And the axis of symmetry. There it is. Okay. All right. Are we good with this part? Again, this is, I think, the harder part. Maybe you might think otherwise, but quadratics are a little bit tougher, I think, personally. Okay. Now, from there, we're going to do number 7 and number 11. Okay. Now, I don't know if you guys remember when we used to graph these, but the greater than and less than signs usually required us to color stuff in, right? We had to like shade above, shade below. The lines we drew were either dashed or solid. But it was just linear functions. So these are supposed to be easy once they're solved for y. Number 7 is already solved for y for us, okay? So I'll use 2 different colors here. So we'll use green for this one. Sorry, not green, red for this one. I'll use green for this next one, okay? Just so you know which line is which. So we'll start off with the red one. Y less than or equal to 2/3 x minus 3. That means I start at -3. You guys remember y equals mx plus b, right? So the b value is where we begin. M is where we move. Our slope is where we move. So I begin at -3. So there, I'm going to put a dot right there. And then I get to move according to the slope, which is 2/3. So up 2/3, here's my second dot. Now, I got to figure out what kind of line to draw. This says less than or equal to. So if it says less than or equal to, it's solid. If it just says less than, it's going to be a dash. Okay? So this is a nice solid line. Okay? Should I shade above or below? Well, since it's less than or equal to, less means below. So here we go. Okay, so there's the first graph. Now I got to draw the second graph. So the green one, I begin at +3. And then my slope is -4/3. So down 4. So 1, 2, 3, 4/3. It happens to be the same dot that's already there. So I'm just going to draw a solid line because that says greater than or equal to. So a nice solid line. Now, I don't know if I'm sure you remember. Hopefully you do. I used to use yellow and blue highlighters because what happens when they cross? They turn green, right? So here we go. I'm going to highlight with blue. And when it starts to turn green, that means that's where my answers are found. Okay? So there you go. There's my graph. So if you use highlighters yourself, the same will happen. But if you're using pencil, just try to use, like when they're crossing, just go a little darker there, right? So you can see where the answer is supposed to be. But as you can tell, this isn't hard to do. You just got to remember how to graph. The only times these get a little bit tougher is when they're not solved for you. So that's why I want to do number 11. And not because it gets really intensely difficult. It's just because now you have to do a little bit of extra work. Okay? So let's do top one is red, bottom one is green. Okay, I'll do the work in red and green. That way you can see which one was which. So here we go. So 5x minus 3y is less than -6. So here we go. 5x minus 3y less than 6. Sorry, not -6, +6. So I got to solve for y. Let's move the 5x over. So that's -3y is less than -5x plus 6. Okay? Then I have to divide both sides by a -3. What am I supposed to do when I have an inequality and I divide both sides by negatives? What do I do to the sign? Right now it says less than. You guys remember? When you divide by both sides of an inequality by a negative number, you got to flip the symbol. Okay, so it's going to become y greater than 5/3 x minus 2. So the symbol is going to flip. Okay, the less than becomes a greater than in our case. So that's good. I can graph this one. Let's go ahead and graph it. My b value is -2, so I'm going to put a point in -2. My slope is 5 up, 3 over. So 1, 2, 3, 4, 5, 3 over. That's right here. It says greater than. So my line should be dashed. Okay, a dashed line. And which way do I shade in, since it says y greater than? Yeah, I don't know what they're trying to fix, but up, right? Yeah, they're trying to fix something in the something with air ducts. I don't know. So if you guys hear something in the background on the recording, it's the air conditioning. So there we go. There's the first one. Now let's switch over to green. Okay, so x minus 3y greater than or equal to negative 6. I'm going to solve for y again. So let's get this x. Let's throw it over. Negative 3y is greater than or equal to negative x minus 6. We'll divide both sides by negative 3. And again, if I'm dividing both sides of an inequality by a negative number, I got to switch the inequality. So I get y less than or equal to 1/3 x plus 2. 1/3 x plus 2. So now let me go ahead and draw that. I'm going to go to positive 2. I'm going to put a dot right there. 1, 3 over. So 1 up, 3 over. That's right here. It's less than or equal to, so it's a solid line. And less than or equal to means shade below, right? Shade below the line. So here we go. And I'm just going to kind of finish coloring everything underneath. But remember, since I'm using highlighters, the green color that shows up, those are my solutions. And that's it. This is what you guys have for homework today.